So for example number 2, determine the maximum speed v which the sliding block may have as it passes point A without losing contact with the surface. So as you can see in the figure, the first part of the space diagram here, it is having a straight surface, and then at point A it is having a at least a circular surface. So the question is, after the block has arrived at point A, what should be its maximum speed so that it will not lose contact on point A? So if we draw a free body diagram as part of the given, let's say this is our object. We have a weight going downward, and since there is a surface, then there must be a normal force. So this should be our T, and this should be our normal axis. So these are all the forces that act on the body: the weight and the reaction normal force. There are no other forces. There is also no coefficient of static friction and coefficient of kinetic friction. So now we're ready to formulate the equation of motion along the normal direction. So sum of all forces along n is equals to MAN, because at that point the surface is arc. Okay? So there must be a normal force that is pushing the object toward the center. So it should be equated to MAN because the surface is arc or circular. So what are the forces? W and N, weight and N. So that would be weight minus N is equals to MAN, or weight minus N is equals to mv squared over rho. Okay, so this is the equation. The weight subtracted by the normal is equals to mv squared over rho. So we can analyze this equation. On the left side of the equation, we have a negative operation, weight minus N. On the right side, we have mv squared over rho. So in order to maximize the value of v, the value of N must be 0, correct? Because N reduces the value of whole expression on the left. But if N is 0, then this whole expression is maximized. Okay, and what does that imply if N is 0? If N is 0, it means that our object is about to fly, and the only force that acts on it is its weight. Meaning, if we maximize this one, the object is about to leave the surface. Okay, so finally we have mg is equals to mv squared over rho, and that would give us v is equals to square root of rho g. So this is the maximum speed of the block without losing contact at point A.